Before we get into today's deep dive, just take a second to subscribe to FarmLab, because what you're about to hear isn't another modern gardening hack. It's a 2,000-year-old soil balancing method recorded in early agrarian texts from Rome, Greece, and parts of the Middle East, used by farmers who had no pH meters, no bottled amendments, yet managed to grow consistent, reliable crops on the same plots for generations. Stick with me for the next minute, because once you understand why this technique worked and why it still works today, it becomes one of the simplest ways to stabilize soil pH without all the guesswork, chemistry jargon, or constant correction cycles. Understanding where this method came from helps us see why ancient farmers rarely faced pH collapse. Early Mediterranean farmers dealt with conditions that would trouble even experienced growers today. Alkaline soils along the coast, acidic soils in oak forests, and nutrient-strained soils in rocky inland regions. With no chemical additives, they relied on natural materials that slowly adjusted soil chemistry without shocking it. The trick we're discussing today appears in Roman agricultural writings by Cato and Columella, and later in Byzantine manuals. The core idea was incredibly simple. Mix fully charred plant matter with decomposed organic sweetening material, usually well-rotted manure or leaf mould, and apply it as a buffering layer rather than a direct soil amendment. This char and humus blend stabilized extremes so effectively that ancient farmers wrote about being able to make bitter soil gentle and temper soils too sharp for roots. The genius of the technique was the slow release. Nothing happened suddenly. The soil shifted gradually into a balanced state and stayed there because the biology, rather than the chemistry alone, did the heavy lifting. The ancient mixture works because char binds acidity, while humus moderates alkalinity. The first component was charcoal, not ash, not half-burnt sticks, but fully carbonized material. Ancient farmers created it during routine brush-clearing burns or in pit kilns. Charcoal has a porous structure that locks onto acidic ions over time, reducing soil sourness. It doesn't dissolve. It doesn't wash away in the rain. It simply sits in the soil, acting like a stable sponge that captures and stabilizes imbalances. The second component was humus, not raw manure, not fresh leaves. Humus meant matter already broken down by fungi and soil, life into a soft, dark, almost soil-like material. This humus brought biological buffering power, the ability of microbial communities to neutralize alkalinity by feeding nutrients back into the soil in forms plants prefer. When paired with charcoal, one balanced chemical extremes while the other balanced biological ones. Ancient farmers never applied the mixture directly into planting holes. They layered it on top first. They understood that letting rainfall, worms, and natural soil mixing bring the material downward prevented roots from hitting concentrated pockets too quickly. That slow incorporation is what prevented nutrient burn and created even long-lasting results. Applying this trick today is surprisingly easy and works in almost every climate. To recreate the 2,000-year-old method today, you can start by making or collecting fully charred wood. Many people produce biochar intentionally, but even the leftover charcoal chunks from a safe, clean wood burn can work. The key is that the char must be fully carbonized. If it snaps cleanly rather than bending, it's ready. Humus can be harvested from the bottom of a long-aged compost pile beneath a leaf heap that has been sitting for a year, or from worm castings. The material should be dark, soft and earthy, not chunky or decomposing. Blend these two materials together. Ancient sources describe a ratio that reads roughly as a handful of char to 2 handfuls of sweet earth. In modern terms, that means more humus than charcoal, enough to coat the char particles without burying them. Spread the mixture over the surface of your garden bed in a thin, even layer. There's no need to dig it in. Rainfall, irrigation, insects and natural soil contraction will gradually draw it downward. After several weeks, pH begins to settle. In badly imbalanced soils, you'll often see improvements in the very first season, with major stabilization by the second. So, a practical modern example is dealing with acidic garden beds, where, tomatoes and beans really struggle. Instead of adding lime all at once, which honestly can overshoot the target, apply this ancient mix in spring. The char moderates acid gradually, and the humus brings biological life back into the soil. In alkaline regions, where gardeners fight yellowing leaves and iron lockout, the humus gradually adds organic acids that ease alkalinity, while the char provides structural balance. This method works long-term because, both components become part of the soil itself. One of the most impressive advantages of this method is, its permanence. Charcoal remains in soil for centuries. Archaeologists find it in fields that haven't been farmed for ages, still performing the same stabilizing role. Humus, meanwhile, is constantly renewed as plant roots, soil life, and decomposed material feed into it. Instead of correcting pH every season with lime, sulfur or store-bought amendments, gardeners who adopt this ancient technique create a self-balancing soil system. Over time, the soil becomes less reactive to heavy rain, mineral imbalances and fertilizer use. It becomes what ancient farmers described as temperate soil, neither harsh nor weak, strong enough to feed crops, and gentle enough for roots to expand freely. If you're someone who has struggled with pH swings, this method offers a slow, reliable correction that doesn't depend on constant maintenance. It's a perfect example of how old-world farming wisdom solved complex problems with simple, stable materials. If you found this breakdown helpful and want more deep historical farming techniques backed by real, practical steps, make sure you subscribe to FarmLab and share this guide with someone who loves old agricultural knowledge as much as you do.